Okay, so 6.5, a linear inequality has an inequality instead of an equal sign. The solution to a set of linear inequalities is an ordered pair that makes the inequality true. When your y is on the left and it's greater than mx plus b, it results in a dashed line. And in fact, if it doesn't have an equal to sign, so if there's no line underneath like there are on these last two, then it's going to be a dashed line. It's like an open circle versus a closed circle when we're on a number line. And we're going to shade above. So let's take y greater than 2 over 1x minus 4. So we put a dot at minus 4 because that's our y-intercept. And we go up to over 1. Until we run off our graph, and we do it the reverse until we run off our graph. Now we're going to make not a straight line like we have been doing before, but because we cannot equal this line, we're going to go dash. So everywhere there's a dot, I'm just going to put a dash. So this is a dashed line, goes there, and then I'm going to shade. So if you have a highlighter or a colored pencil or something of the other method, go ahead and get that out. If you don't, I'm going to pass around some crayons. We only have one equation here, so we only need to do one. So we're going to, you put your crayons on your line. So I'm just going to wait so you guys are quiet. You put your crayon on your line, and then you shade everything greater.
Oh, but that's negative side.
You are not looking at right or left. You're looking at above or below. So you put your crayon on your line, and you shade above. It doesn't matter if the x's are negative or not. You're concerned with the y's being greater. As long as the line's dashed, you should be good. All right, so let's look at when you have y less than mx plus b, you have the dashed line, but then you shade below. When you have y greater than or equal to mx plus b, I remember this because line means my line is solid. If I have a line in my inequality, it means I have a line on my graph. If there's no line on the inequality, it's a dashed line on my graph. And then when you're greater than, you shade above. When you're less than, you shade below. So when you have y less than or equal to mx plus b, it's a solid line, and then you're shading below. So put your shading pen or pencil or crayon on your line, and then only color in what's below. So I'm going to go ahead and graph this y less than or equal to negative 3/4 x plus 4. Plus 4 is going to go here. Our rise is going to be negative 3. And our run is going to be 4. It's going to go down 3 over 4. And it's going to be a straight, solid line. Then you're going to take your shading, which for me is the crayon. For me it's a crayon. You're going to put your crayon on your line, and then you're going to shade everything below.
This is going to be the other color.
Yeah, so make this a different color. we're going to test to see if a point is in our shaded region. So the question here for problem 1 says, is the ordered pair a solution of y greater than x minus 3? So where the x is, we're going to put 1, and where the y is, we're going to put 2, and it's either going to be true or false. If it's true, it's yes. If it's false, it's no. So y is 2 greater than x minus 3. Go ahead and do the math on it. 1 minus 3 is negative 2. Is 2 greater than negative 2? Yeah. So this is true. So the answer is yes. 1, 2 is a solution. To write all of it. It took me 3 seconds. I think it's okay for you to invest the time. So we're going to test our other point, x and y. So where the x is, we're going to put a negative 3. Where the y is, we're going to put a negative 7. So we get negative 7 greater than. We're going to go ahead and do the math. Negative 3 minus 3 more gives us negative 6. Is negative 7 greater than negative 6? And think about where they are on the number line. Who's closer to 0? So this is false. So then it's no. Negative 3, negative 7 is not a solution. All right, you guys give it a whirl. We have a little bit of a fraction right now. Y less than or equal to 2/3 x plus 4. Let x equal 3 and y equals 6. See if you can simplify it down so you can tell whether it's true or false. All right, so we are going to put in 6 for the y and 3 for the x. That's like multiplying by 3 over 1. So that's 6 less than or equal to 6 over 3 plus 4. 6 over 3 is 2 plus 4. Is 6 less than or equal to 6 plus 4? Or sorry, 2 plus 4. So that's a true. It's actually technically equal to it. So 3 comma 6 is a solution. Okay, so we're going to graph some inequalities, and it's saying testing points for the shading. So once you graph it, you want to see if you did your graphing correctly. So you want to pick a test point within your shaded region, and I always pick 0, 0 if it's an option, because it's super easy to plug in 0. If that's not easy, then I try 1, 1. So I can plug in 1 and multiply by 1. Or something with a 0, comma. If those two aren't an option, something with a 0 in it. So let's go ahead and graph this. This is the same as 1x, which is the same as 1 over 1x. When I compare it to y equals mx plus b, our b is negative 2. And our m is 1, and that's 1 over 1. So when I graph it, it's going to be up 1 over 1. So go ahead and put those dots on your graph. Go all the way across your graph until you run out to the left and to the right. And we now need to decide, is it a dashed line or a solid line? Dash. So everywhere there's a dot, make it a dash. Woohoo! And we want y greater than. So we're going to put our crayon on the line. And we're going to shade, just go straight up. We're going to shade everything above our line. And yay! My favorite point, And our testing is inside our shaded region. So let's pick 0, 0 as our test. So if we drew this correctly, if we plug in 0, 0, we should get a true statement. So we're going to make y 0 and x 0. Is 0 greater than negative 2?
No, yes.
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 Yes. Would you rather have nothing in your checking account or negative 2 in your checking account? Nothing, because if you have negative 2, they're going to charge you $20 for an overdraft. So 0, 0 is a solution. Oh, I don't need to print this one. 0, 0 is a solution, and we know we've drawn this correctly. All right, so let's go ahead and graph all these out, and we have a couple of special graphs, y greater than 4 and x less than or equal to negative 2. So you guys graph these as I graph them. So this is our y-intercept at 1. This is up 1 over 2. And it is solid. And we want everything less than this line. So we put our crayon on the line and we go everything below. Think about this. This is a horizontal line at 4. So I'm going to find 4 and make a horizontal line, but it is dashed because it doesn't have a line underneath. This is a dashed line along the horizon. Then we're going to put our crayon on this line. And we want everything greater than 4, so that's above. One thing we didn't do on this first problem is to pick our practice point. So I'm going to pick 0, 0 because thankfully he's in our shaded region. I'm just going to test 0 less than or equal to 1/2 times 0 plus 1. 1/2 times 0 is 0. Is 0 less than or equal to 1? Check. I don't have 0, 0 in this scenario, so I'm going to pick a point. I'm going to let it be 0, 5. The next best thing is x is still 0, and then y is 5. So if y is 5 greater than 4?
Yeah.
Check. Remember, when we have just an x, it is a vertical line, so it's straight up and down at the place where x is equal to negative 2. And this has a solid, it's a line underneath, so we are going to have a solid line. And then we want everything less than negative 2. That's easy enough. It's not up or down in this case. We want all of our x's less than or equal to 2. So that's all this stuff right here. Less than or equal to negative 2. We're going to pick our test point, and 0, oh, sad panda, my 0, 0 isn't in here. So let's pick negative 3, 0 as our test. So when x is equal to negative 3, is that less than or equal to negative 2? It is. Negative 3 is smaller than negative 2. Okay? All right, what do you do when you don't have the y solved out? We just have to solve for y and then graph it. The trick is, if you multiply or divide by a negative, you have to switch your sign. So write that down. We are going to be on the lookout for when we multiply or divide by a negative, our sign switches. So we want to make sure we don't get bamboozled by that. So in this case, I want y on the left and everything else on the right. So I'm going to subtract 5x from both sides. I'm going to write the x's first because I'd like to have the slope first. So that's negative 2y greater than negative 5x plus 10. Then we're going to divide both sides by negative 2, which means everything gets divided by negative 2. And now we're in penalty zone. We're actually technically dividing by negative 2. So my sign is going to switch. So it was greater than, now it's going to be less than. Make sure you switch your sign. Negative and negative give me a positive 5 halves x. Positive 10 divided by negative 2 is negative 5. Then I'm going to go ahead and multiply, go ahead and graph it. We start at negative 5. We go up 5 over 2. And we are a dashed line because we don't have a line. In our inequality. We want y less than our line, so we put our pencil on our line or our crayon on our line and we go less than. Everything below. Let's pick a point to make sure we didn't go awry in our solving. So let's pick 3, 0. So x is 3 and y is 0. I'm going to start with this one, because if I go here, what if I did my math wrong? And then it would still be wrong if I plugged in the number. So I'm going to start here. I'm going to put 3 in for x, 0 in for y. I'm going to see if that's greater than 10. So 15 minus 0. Is that greater than 10? Is 15 minus 0 greater than 10?
Yes.
Yeah. So we gotta check. All right, we're gonna do, let's go ahead and solve these two equations. So we subtract x from both sides and divide by 3. I put negative 1x because I know I'm going to have to graph a slope. So I want to make sure I graph that slope correctly. So then I divide everything by 3. 3 is positive, so it keeps my inequality the same. So y less than or equal to negative 1/3 x plus 2. Let's see. So let's go ahead and graph this. We start at positive 2. We go down 1 over 3. We run out of graph and then we go backwards. This one is an equals to, so it's a solid line. And we take our crayon. And we want everything equal to or below, so that's down. Everything down here. Thankfully, 0, 0 is in our feasible region, so let's use that as our test. So when I put in 0, plus 3 times 0, is that less than or equal to 6? So 0 plus 0 gives us 0, and that is less than or equal to 6. All right, I can already see in this next case, I'm going to be dividing by a negative. I can see that because I have a minus 4y. So we're going to subtract the 8x. Negative 4y greater than negative 8x plus 24. Remember, I like the x's first. We're going to divide both sides by negative y. We get y greater than negative 8 over negative 4 is 2. And 24 divided by negative 4 is negative 6. Let's go ahead and, oh sorry, we have to switch the inequality. Eraser, but I want it small. Just switch this inequality because we divided by a negative. This inequality switches to less than. So we go down to negative 6. Our slope is 2 over 1. So it's up 2 over 1. So we run out of graph. And it is a dashed line. Okay, we want to color everything below the dashed line, so that's this. Unfortunately, 0, 0 is not in our test zone, but 4, 0 is. So let's go ahead, and for x we're going to put in 4. For y we're going to put in 0. And see if that's greater than 24. That it gives us 32 is greater than 24, and that